Now we're going to talk about naming cyclic alkenes. And it follows the basic rules that we've learned with other nomenclature systems, but there is a really important feature when naming cycloalkenes, and that has to do with the numbering. In cyclic alkenes, you're going to have a double bond in the ring. That double bond is always carbon 1 and 2, regardless of any of the other carbon substituents in the ring. If we have the alkene, it's going to be carbons 1 and 2. Once you've made the alkene 1 and 2, then you number in the direction that gives the lowest substituent numbering. So it's a little different than how we did with cycloalkanes, where we added up the numbers. So let's look at an example. If we want to name this, we need to first figure out our numbering. And we know the alkene has to be carbons 1 and 2. But do I make it 1 and 2 like that? Or do I go in the opposite direction and make it 1 and 2 like that? What you want to do is continue around the ring and from there figure out your lowest substituent numbering. So for our first case, we end up with a methyl at 6. And our other scheme, we end up with the methyl at 3. This numbering wins. We have a 6-carbon parent. Remember the cyclic portion, so write cyclo. And it's 6 carbons, hex, but because we have the double bond, we add the ene ending. When we write the IUPAC name for this, we alphabetize our substituents. Here there's only one, so we just write 3-methyl cyclohexene. A couple of other things to be aware of when writing cycloalkene names. There's no need to include an E or Z designation because the double bond in a ring is always going to be kind of in this cis form because a trans double bond can't fit inside a ring. So you don't need E and Z. And you don't need to specify the 1 before the alkene, before the ene, or before the cyclohexene because we know the double bond in a ring is always at carbon 1. Now let's work on naming this compound. So as before, we need the carbon 1 and carbon 2 at the double bond. And it's probably very, very tempting for you to want to say this should be 1, this should be 2, because then that gives us chlorine at 3. Well, that's not the way the rules work for cycloalkenes. If you have a substituent on the double bond, regardless of anything else, this carbon gets priority as the number 1 designation, even if it results in an overall higher numbering scheme for the other substituents. If there's a substituent on the double bond, that immediately gets the number 1 designation. And from there, we'll continue around our ring. So the other carbon of the double bond is 2. And we end up with the chlorine at 7. So that's the correct numbering for this. So now we have our parent, which is going to be cycloheptene, and we have a substituent, the 7-methyl, and the 1-methyl. So putting this together, we alphabetize our substituents and follow that by the parent. And we end up with 7-chloro, 1-methyl, C comes before M alphabetically, and cycloheptene as the parent. Let's look at a couple other examples in terms of numbering, just to make sure we can pick which carbon should be carbon 1. Now in this case we have the alkene, but now we have a substituent on each carbon of the alkene. So now, because we can't pick one over the other because of a substituent, now we're kind of back to saying, well, make one carbon 1, one carbon 2, and then number to give the lowest substituent numbering. So don't worry about the identity of these groups, because we can make a decision based solely on numbering. So I can make this carbon 1 and this carbon 2, and then that puts my other substituent, the methyl, at 3. That's going to be the preferred numbering there. So you should practice and see if you can write the IUPAC name for this compound. In this second example, now we have a substituent at each carbon of the double bond, but there's nothing else on the ring to help us break the tie. So here we have really an absolute tie. And when there's a tie you can't break based on numbering, then you resort to alphabetical priority. So here we have a chloro versus a bromo. The bromo gets priority. That'll be carbon 1. This will be carbon 2. If you write the IUPAC name for this, you should get 1 bromo, 2 chloro, cyclohexene.